So today we are learning about subtracting integers, and one of the main things that we're going to be doing today is getting rid of those double signs. Adding a negative, we'll deal with double negatives, okay, and we're going to write our equations in a cleaner way. So in example 1, we're going to cover several different concepts within this example. In the first example, I have 2 minus 7. Now the rule still applies that I need to look and see if I have same sign or different, okay? Do I have same sign or different here? And what you need to remember is that every number has a sign, and the sign is in front of the number. Okay? Every number has a sign, the sign's in front of the number. So, is 2 positive or negative? Positive. Is 7 positive or negative? Negative. It is negative because there's a minus sign in front of it. And remember, we talked about this yesterday. Minus sign is the same thing as a negative because you're taking away either way you look at it. So, same sign or different? Different. They are different, so what do? Subtract. Is my answer 5 or negative 5? Negative. It is negative 5. Very good. All right, now on B we have negative 6 minus 8. So I ask myself, same sign or different? Same. They are the same. Both of them are negative. Well, you say, well, that's a subtraction sign in front of 8. Exactly. You're taking away. That's negative. That's the same thing. So, since I have same sign, what is my rule? Add and keep. So what's my answer? Negative 14. Negative 14. Add them together and keep your common sign. All right, now what if you had 12 minus negative 9? Now this is one that we haven't talked about yet. When we have a double negative, and a double negative means that you have two subtraction signs or two negative signs right next to each other without anything in between them. Okay? That is what you call a double negative. Not meaning that, okay, there's two negatives in the expression, so that's a double negative. No, that's not what it means. They have to be back to back, one right after another. That's what we call a double negative. And when we see that, we change it. It's almost like they cancel out. And they cancel out to make a positive. 12 plus 9 is 21. So anytime you see a double negative in an expression, the first thing you need to do is change it to a positive. And you only change that part of the expression. That's the only time you're going to change a sign. Okay, is when you have a double negative. All right, one more example. What if we had negative 10 minus negative 5? Based on what I just said, what's the first thing that you want to do here? Horsey?
Take away the minus?
No. Don't take away a minus. Okay, Kevin?
Cancel it out.
You cancel out what?
The negative sign.
The double negative changes to a positive. But notice that negative 10 stayed the same. I don't change any other signs in my expression except for the signs where the double negative changes to a positive. That's the only one that I change. If there are other negatives in the expression, those stay the same. Okay? You only change the double negative. And then negative 10 plus 5, different signs, subtract and take. What's your answer?
Negative 5.
Negative 5. All right, now I want you to go ahead and do numbers 1 through 4 on your turn now, the bottom of page 266. All right, so let's go over this classwork real quick. Number 1 was 4 minus 6. Same sign or different? Different. 4 is positive, 6 is negative. Okay, remember, every number has a sign. The sign's in front of the number. Okay, so 4 minus 6 is what? Negative 2. Subtract and take. Number 2, I have negative 7 minus negative 8. All of you were very good about changing that double negative to a positive. So now you have negative 7 plus 8. Remember, the double negative only changes that part of the expression. The other signs will stay the same. Negative 7 stays the same. Now, and I'm surprised at how many people did this, your answer is positive 1, not negative 1. Because 8 is positive. All right, remember, once you change that double negative, that's the new expression. So you want to look at those signs. Your answer is positive 1. All right, now in number 3, you have negative 2 minus 1. Same sign or different?
Same.
It's the same, so what do? You add them. Negative 3, add and keep. Okay? 2 is negative, 1 is negative, so add them together and keep your negative. Now in number 4, you have 15 minus negative 3. Change your double negative to a positive. 15 plus 3 is 18. Raise your hand if you got all 4 right. Okay, very good. Very good. Okay, if you missed something, do you see where you went wrong? Do you see where you went wrong? Okay. All right, now in example 2, now we're going to apply this principle to a word problem. It says the highest point in Asia is Mount Everest at 8,850 feet. The shore of the Dead Sea, the lowest point in Asia, is 410 meters below sea level. So how would I represent that as an integer? Negative 410. Okay, so there's my two integers, 8850 and negative 410. And it asks me now, what is the difference between these elevations? So difference means what operation? Subtraction. Okay, so do you see anything kind of odd about this expression, Zach? You have a double negative, so you need to put 410 in parentheses to separate your double sign. And now that's the first thing that you're going to address is that double negative. 8850 plus 410 gives you 9260 meters. 9,260 meters. Okay? So the first thing you do is you write down the integers. Mount Everest is 8850. Dead Sea is negative 410. And then you figure out what operation connects them. And in this case, it was subtraction, so I ended up with a double negative. All right, any questions on this? Anything? Justin?
What do they mean by integer subtraction?
Integer is just a whole number. That's just, integers is how we would basically define a number. Okay? But a fraction is not an integer. It has to be a whole number. All right, any other questions? Okay, moving on to example 3. Now you're gonna have to hang in there with me for a minute here, okay? Now let me ask you this: if you were to imagine a thermostat for a second, okay, and nobody make fun of my drawing because it will hurt my feelings. All right. I can't draw a thermostat. All right, so imagine it's just like a thermostat like this, and there's like different temperatures and degrees. Okay? And imagine you start at, what is the starting temperature? 63 degrees. So we'll just say it's up here somewhere, 63 degrees. And then you end up at negative 21 degrees, way down here. Okay? They want to know the change in temperature. Well, anytime you're looking to find the change in temperature, the change in anything, okay, you're going to be subtracting, right, to find the change. But here's the problem. You're going from a positive number to a negative number, okay? So first, how many would it take for you to get from 63 to 0? You would go down 63 degrees, right? Well, then how many would it take for you to get from 0 to negative 21? 21 degrees. So how could you figure out the change? You would add them together. You would add them together, but would your answer be positive or negative? Which direction is the temperature going? Is it increasing or decreasing? It's decreasing, so I would say that it decreased by how much? It decreased by 84 degrees. 84 degrees. Do you see that? Do you see how, now I know that my thermostat is lacking, to say the least, but do you see how we figured out what the change was? If you go from a positive 63 degrees to a negative 21 degrees, you have to add them together because you go through 0. You have to drop 63 degrees to get to 0, and then it's 21 more. Okay? So you add them together, and it's negative because it was a drop in temperature. Does that make sense? A little bit, maybe? Okay, now I want you to practice a couple. I want you to do numbers 5 and 6 on your own, and don't forget to label your units. Me. All right, so on number 5, it says, find the difference between an elevation of 535 feet. And remember, the first thing you're going to do is just write the integers. So 535 feet above sea level would be 535. And 8 feet below sea level. So how would I represent that integer? Negative 8. Now it said, find the difference. So I know that I'm subtracting. Negative 8 goes in parentheses. And 535 plus 8 is 543 feet. Okay, raise your hand if you got that right. Very good, very good. Okay, so write the integers first and then connect it with the operation. Now on number 6, it says temperature at 6 a.m. was negative 12 degrees Fahrenheit. I'm sorry, yes, at 3 p.m. the temperature was 32 degrees Fahrenheit. So now here's our fancy little thermostat. Okay, and we just have a bunch of hash marks. Obviously, this is not going to be drawn to scale, but we're just kind of illustrating the point. You don't have to do this on your homework. So you start at negative 12 degrees Fahrenheit. We'll say 0 is right here, degrees Fahrenheit. And then you end up at 32 degrees Fahrenheit. Okay, what is the change in temperature? Well, how many do you have to go from negative 12 to 0? 12. And how many do you have to go from 0 to 32? 32. So how do you figure out the change? Add them together. 32 plus 12 is what? 44. And is my answer going to be positive or negative?
Positive.
Positive, because the temperature is increasing. It started at negative 12 and it ended at positive 32. So my answer would be 44 degrees Fahrenheit. Okay? Do you see that? Do you see that? It might actually help you if you do draw. I mean, obviously you don't have to be a master artist, but if you do draw like some kind of picture on some of these word problems for your homework tonight, it might help you figure out the answer. All right, if you understand that, that's everything you need to know for 6.3.